back to our review. Now I have cosine x cosine pi over 5 minus sine x sine pi over 5 is equal to square root of 3 over 2. And my goal here is to find the general solution and to find all particular values between 0 and 2 pi in case it's x, or between 0 and 360 if I have theta. Here I have x. First thing is to condense this one. If you look at your green paper, this whole thing is actually cosine of x plus pi over 5. That should be equal to square root of 3 over 2. So I can say that x plus pi over 5 is equal to the cosine inverse of square root of 3 over 2. From here, I will say x plus pi over 5 is equal to cosine of square root of 3. That will be pi over 6 plus 2 pi n. Or x plus pi over 5 is equal to negative pi over 6 plus 2 pi n. Well, I will move the pi over 5 to this side, and if you want to know this, pi over 6 minus pi over 5, the common denominator is 30. You will multiply this by 6 and this by 5. That will be 5 pi minus 6 pi. So this here, if I subtract, I get negative pi over 30 plus 2 pi n. Compared to this, if I add, I would end up with x is equal to 11 pi over 30 plus 2 pi n. And that's my general solution. If I want to know all the specific solutions, I would say 11 pi over 30 is one of them. The next one will come from here, and if I multiply this, that will be 60. That will be 59 pi over 30. Those are the two solutions possible for this. On problem number 16, we have all these instructions. So I will start by building A and B. This is for A, the red one. So I will say, I know that the sign of A is positive, and I know that all students take calculus. If the sign of A is positive, it will be located in this quadrant. Let me highlight this. In this quadrant or in this quadrant. And if the cosine is negative, well, the cosine is positive here. It can only be in this specific quadrant. So I will build my triangle here. All right, this is angle A. So for this, I was able to figure out that it's in this quadrant. So the sine of A is 3 over 5. So that means the opposite is 3. The hypotenuse is 5. Therefore, the adjacent will be 4. Note that it's still for angle A. Let's do the same thing this time for angle B. So here's my angle B. For my angle B, I know that all students take calculus also, right? And I know the tangent is positive. So it's either here where all are positive or where the tangent is positive. And I know the sign is negative. It cannot be here because the sign is positive here. So I will build my triangle down here. And I can label it. And to label it, I know that my opposite is 1 and my adjacent is 2. They are both negative, that's why I have 1/2. Using your Pythagorean theorem, that will be 4 plus 1 square root of 5. At this point, I can easily find out the sign of A plus B. Knowing that the sign of A plus B, if you expand it, is actually equal to the sine of A times the cosine of B plus the sine of B times the cosine of A. So I will go ahead and use my triangles to find out. For A, the sine is, by the way, this is negative 4. The sine of is 3 over 5. For A again, the cosine is negative 4 over 5. For A. I'm just messing both with A first. Now for B, the cosine is negative 2 over square root of 5. And the sine is negative 1 over square root of 5. And all I have to do is multiply and add. If I multiply on top here, I get negative 6 over root 5. Plus, I multiply here, I get, and I multiply here, I get 5 over 5 root 5. I will not try to simplify. I'm sorry, 4. I will not try to simplify anything. I will just go ahead and combine. 4 minus 6 is negative 2 over 5 root 5. You do not need to rationalize at this point, but if you wish to do so, this is equal to negative 2 square root of 5 over 25. I can take any of these two answers.